All right, so in this lesson, we are going to create a table of solutions given the slope-intercept form of a linear function. So remember that slope-intercept form is y equals mx plus b, where m is your slope, also known as your constant rate of change, and b is your y-intercept. All right, so we have f of x equals 3 over 2x plus 1. So we know that our y-intercept is right here. So our y-intercept, which is b, is 1, but it's actually 0, 1. Remember, we need an x and a y, an x and an f of x. So we start at 0, 1. Our slope is 3 over 2, so our m is 3 over 2. So, and another way we could write that slope is 1.5. Y'all know how to do that. So our slope is 3 over 2. So change in y, change in x. Let's change, how much do we change y by? Well, we increase it by 2. Oh, that is incorrect. It increases by 3. So 1 plus 3 is 4. When the x increases by 2. Remember, 3 over 2. 3 over 2. So we will go up another 3 when we go up another 2. Oh, this time we're not going up 2, though. We're going up 4. We're going up 4. So instead of going up 3, we should go up 6. Because remember, this, we increase x by multiplying by 2. Like 2 times 2 is 4, 3 times 2 is 6. So 7 plus 6 is 13. Now, if you're having trouble with this, first I want you to do a couple with the arrows, right? With the slope. I want you to show me. But if this starts causing you some trouble, then I want you to go to Desmos, okay? Let's go to Desmos. Go to our graphing calculator. And we have, well, let me remember. F of x equals 3 over 2x plus 1. F of x equals 3 over 2x plus 1. And then we can click this little cog right here where it says edit list and convert it to a table. You can always check your answers. 0, 2, 4, 8, 50. 0, 2, 4, 8, 50. So we have 1, 4, 7, 13. Let's see if that's right. 1, 4, 7, 13. Cool. And now we have a 50. So with the 50, since it's like way higher, like we have to increase this by 42, let's just go ahead and write the answer that we get. So 50, 76. This is just in case you're ever asked to get something like 100 or a decimal or something. Like you can always just like look in a calculator. It'll tell you, it'll do that part of the work for you. So let's prove that we're not completely incorrect. But this time, let's go ahead and use this f of x version. Usually we use the y equals version. Let's use the f of x version. So I'm going to choose 4, 7. All right, 4, 7. So I'm going to use this version, the function form of our equation. So remember that this is our x, this is our y, which is the entire f of x. Well, I'm going to show you a different way. So we're going to put an x. X goes here. But x, changed colors for some reason. But x we can also put here. Not for the whole thing, but you'll see. So f of 4 should equal 3, well, equals 3 over 2 times 4 plus 1. So it's important that you put your solution here. It's important that you put a solution here, okay? So this part will stay the same. So f of 4 equals, this is over 1, so 3 times 4 is 12. 2 times 1 is 2. Plus 1. So we get f of 4 equals 12 divided by 2 is 6. Oh, I forgot we're doing that. So 12 divided by 2 is 6 plus 1. So f of 4 equals 7. 4, 7, 4, 7, 4, 7. So that's good. That's what it was supposed to be, according to what we did, and the Desmos. So let's choose a non-solution. I think non-solutions, like, you obviously can pick random numbers. You have a very small chance of guessing like a correct one by mistake. But it's still possible. So what I like to do is take one. Like I picked 4, 7 before, and 4 goes with 7. So 4 would not go with like 9 or something, right? So you would do the work, and it'll say f of 4 is 9, which is wrong. So I'll show you that. So 4, and this will be an easy way a faster way of doing some of the work, and you'll see why. So f of x equals 3 over 2x plus 1. Just remember that this goes here, and it also goes here to show us what we plugged in. So f of 4 equals 3 over 2 times 4 plus 1. We already did this part, so 3 over 2 times 4 when we did it was 6, so we could put 6. F of 4 equals 7. So if you look here, in this one, it was correct, because f of 4 was 7. So when x was 4, y was 7. When x was 4, y was 7. But in this one, we would count this as incorrect, or this is proved, because we said that f of 4 would be 9, but when we did it, f of 4 was 7. So in the next one, I'll do it slightly different, just so it looks more like what you're used to. This is wrong. Okay. And so f of x equals negative 5 over 3x minus 4. So our y-intercept is 0, negative 4. Remember to carry that negative there with it. So a lot of you may want to put the negative 4 here because it's first, but remember the negative 4 goes across with the 0. And our slope is negative 5 over 3. So actually, let's go here. So our y-intercept, which is b, was 0, negative 4. Our slope, which is m, let's see, which is m, is negative 5 over 3. I can write that a little better. And another way we could write that is negative 1.66 repeating. So change in y and the change in x. So the y, so we will decrease by 5 if we increase. Remember, this is a plus 3. Or we can treat it like a plus 3. If we increase by 3. So negative 4 minus 5 is negative 9. And we can decrease by another 5 when we increase by another 3. Yeah. Negative 9 minus 5 is negative 14. And this is where it gets a little weird. So here's a reminder too. If you want to go backwards, like so to speak, you have to do the opposite. So instead of adding 3, we will decrease by 3. But instead of subtracting 5, we will end up adding 5. So negative 4 plus 5 is positive 1. Let's go to Desmos. Negative 5 over 3x minus 4. Negative 5 over 3x plus 4. Oh, minus 4. Okay. And then negative 3, 0, 3, 6, 16. Negative 3, 0, 3, 6, 16. So we have 1, negative 4, negative 9. 1, negative 4, negative 9. Negative 14. And 16 goes with negative 30.66 repeating. I guess I could write that a little bit. There we go. So let's prove one solution. Now, I showed you this way, but I'm going to show you the way that you're probably more familiar with that we usually use. So I'm going to use 3, negative 9. So let's see. Remember that this is x, this is y, also known as f of x. And so we have f of x equals negative 5 over 3x minus 4. So we have, let's see, this will replace the x, this will replace the entire thing. So we get negative 9 equals negative 5 over 3 times 3 minus 4. So we get negative 9 equals, so negative times a positive is a negative. 5 times 3 is 15 over 3. And negative over positive is a negative. 15 over 3 is 5. Negative 5 minus 4 is negative 9, which is what it was supposed to equal. And non-solution. So I'm going to choose like 6, 10 or something. 6, 10, because 6 is supposed to go with negative 14. So 6, 10. This is x. This is f of x. So f of x, which is 10, should equal negative 5 over 3 times 6 minus 4. So I know that 6, here's another shortcut, so 6 divided by 3 is 2. 2 times 5 is 10. So negative times positive is a negative. If you need to show the work for that, you're fine in showing the work, because 5 times 6 is 30. And then you'll divide it by 3, which is 10. So negative 10. Negative 10 minus 4 is negative 14. And 10 does not equal negative 14. I can make that whole thing. Ooh, I think I made it worse. Okay. 10 does not equal negative 14. And that's it. Thank you.